let's start doing some differentiation. And first of all, the rule that we're going to be using is that if y equals ax to the power of n, then when you differentiate it, your derivative dy by dx is going to equal n times ax to the power of n minus 1. So the n comes and multiplies in front, and then the power of x decreases by 1. So this is the rule that we're going to be using when differentiating all these functions. And so let's start with saying that we have a function y equals 3x squared. And let's apply this rule to this function here. So I'm going to write down dy by dx because that's what we're trying to calculate. And the n value in this case is 2. So the 2 is going to jump down in front of a function, and then we're still multiplying by 3x, and the power of x is going to be reduced by 1, so to the power of 2 minus 1. So if we multiply this out, we got 2 times 3 is 6, and x, and then we've got 2 minus 1 in the power, which is x to the power of 1, and 6x to the power of 1 is just the same as 6x. Okay, so let's do another one. If our function instead was that y equals x to the power of 4, and we want to differentiate this, we write down dy by dx equals, so 4 comes down in front, so we've got 4 times x, and then the power is reduced by 1, so we get 3, so 4x cubed. And we can't simplify this, so we'll just leave it as it is. Okay, so one more example. If our function y is equal to 2x to the power of negative 3, we can use this same rule even if the power is negative. So we're just going to write down dy by dx, and then negative 3 is going to come down in front, so we've got negative 3 times 2x. And now we have to be careful because we have to reduce the power by 1. So the new power is going to be minus 3 minus 1. So let's see what we get here. So we've got minus 3 times 2. That's going to give us minus 6. And then we've got x to the power of minus 3 minus 1. And that's negative 4. So remember that we're always reducing the power by 1. So if it's negative, it's going to become even more negative. So we get x to the power of negative 4. And this is actually the same as minus 6 over x to the power of 4. So you can also write it like this. So this is the gradient function when the function was 2x to the power of minus 3. Let's do one last one, which is if y is equal to 5x, and we want to differentiate this. So we have to be a bit careful with this one because 5x on its own is the same as x to the power of 1. So if we apply this rule, then the power is going to come down in front. So we've got 1 times 5, and we've got x to the power of 1 minus 1. So we're reducing the power by 1. And then we multiply this out. So 1 times 5 is just 5. X to the power of 1 minus 1 is 0. So we got x to the power of 0. And anything to the power of 0 equals 1. So this is just the same as 5. And we can see that this agrees with what we knew about straight lines, because when we have a straight line y equals mx plus c, then this number in front of the x is always the gradient. And when we have y equals 5x, then 5 should be the gradient of this line. And as we see here, when we differentiated it, we got the number 5, which is good. So that's what we're expecting to get, because that's the gradient of the line.